Hi everyone, it's Has, and today we are going to do our third simulation on ANSYS, and it's gonna be a beam. I'm going to create a beam by the geometry tools, but first I'm gonna grab this. And let's put it right here. First of all, let's go to the engineering data. So today, I will use the nonlinear material properties as well, because I want to study the plasticity of my structure. So here, if you look at down here, you can just see the isotropic elasticity, but you don't see the plasticity. So you can do it for two different manners. For example, now we can right click in here. Click in here and slide it into this window and then assign it yourself. But there is another method. I can just delete and then go to engineering data sources and then go to general nonlinear materials and come up here and choose what I want. And what I want is the structural steel nonlinear. I click on the plus. So now we're fine. So I have my structure. So if I look down here, I have the density, isotropic elasticity values, data, and I also have the plasticity data. So let's go to megapascal. Here, megapascal. So this means this is the yield strength. If the stresses reaches this, the material will start going plastic. And that's what I want to see is my material going to be plastic or not. So I'm going to set up in a way that my material goes to plastic so you can see how to identify the plasticity zone when you have this kind of. What I can do is to right click here and then go to new space claim, for example. So new space claim, we can do a lot of things, I can either choose new space claim or go in new design modeler. For me, it's the same, but space claim is already fast for me to do it. So I'm gonna do it right here. But what I can do right now is to go to a rectangle, for example. So in rectangle, I can do like that. Let's say this is 7 millimeter. No, let's go till 50. Let's go till 50. I can give dimension here. So then I can assign 50 and then give to the other side. So this is going to be 50 millimeter. And now I can just go in design and then choose pool. And by choosing pool, we can grab it like that. Here, let's say 600. 600 is fine. So let's go 600 millimeter. So now I just finished with my geometry. I can just close it. So when I close it, I can just go and model directly. So now we have our geometry. So what I would do is to look at the tree. First of all, you look at the tree, you can see this question mark. That means something is missing. So if you extend a little bit, you can see it here in the material section. You need to assign. So I already defined these material properties. So I'm going to assign it to my model. So now it's fine. We can see here the mark here. Now I can close this and then go to mesh. I can right click and click generate mesh. So when I click generate mesh, we can see this is a pretty good mesh. This is a pretty good mesh. So what I would do is to check the quality of the mesh in order to see if this is a good mesh. I already know it's a good mesh, but I just want to show you this. You can see it's pretty close to 1, so we're good. What I can do as well is to go to here in element size. This is element size. So if I extend a little bit, you can see it's row n element size. So I can either put 5, 10, 20, whether I want, but I just keep the default value as this doesn't bother me. So what I would do is to apply a fixed support, right click, fixed supports right here. So in fixed support, what I would do right now is to what I can do is to look at the origin, because the fixed support I can apply in this section, I mean this side or the other side. So if I click in coordinate system, I can see this is the origin. I'm gonna rotate it and bring it to here, and then I'm gonna apply here my fixed support. So apply, fixed support apply. Let's extend this. So fixed support apply. So now I'm going to apply the load. I already have the fixed support. Now the load, right click, insert, and then force. But right now it's going to be a compression force. I'm going to cause a compression. No, or let's say a flexion, not compression. It's a flexion. Because, you know, instead of having a traction, I'm going to add a load and compression. So let's choose this, the edge. And then the edge, I click right here, equal. And then let's go back here and choose components instead of vector components. And then it's going to be along z-axis. So I'm going to apply a load of, for example, 12,000. 12,000 should be fine. And then right click here and solve. So it's going to be pretty quick to solve, as my geometry is not difficult, you know. So now it's finished. I can add what I want to see. I want to look at this trace boundaries. Also want to see the deformation total. Also want to see the strain equivalent total. Then I can right click and evaluate the results. And now the stress value is 295. So we can see that we exceeded the yield strength, you know, because the limit is 250. So that means we are in plastic deformation. If I want to see very, very quickly, or I don't know, if you want to see it very well, let's go to graph and click this. So you can see that it gets plastic, but we don't see really well. We can exaggerate here so you could see very well. So this is how we have it. You know, our beam is not in the horizontal axis anymore. It's not horizontal, but we can see. We can exaggerate more than that. So you can see this. This is how we have it. You can click here and see the animation. So this is really, really impressive to see. What we can do as well is to generate a graph. Let's say we add this, let's say stress, a new stress, and then let's choose this, the nodes, and let's say we want to capture the stress here, the stress, you know, the stress strain graph in here. Let's go strain, equivalent total. So now I have this. I can right click, you know, these two. Let's evaluate first. Let's evaluate the results. And now I have my results in this node. And let's take these two, and say, no, I don't right click. I'm going to home and then go to charts. So if I click on chart, I'm going to have a graph. Let's click on graph. So if I extend a little bit, I can see the graph right here. What I would do, I want to have the stress strain graph. So that means in this, you know, in the horizontal axis, I want to have the strain. So let's go axis, let's go to strain. So strain is going to be the equivalent strain, the second one, this one. I can't see the x-axis, the strain max, this one, the strain max. And then let's get to here. This is the equivalent stress to minimum. I don't want to see it. So let's omit. I don't want to see the time. The time is going to be omitted. And the stress maximum, this is the one I want to see. And the strain minimum, I'm going to omit it. So if I omit it, we can see here our graph. So this is our stress strain graph. So another thing I can teach you is to tell you that here in ANSYS you can generate a report. So how to do it? You can just go here and manage and go to reports. Where is report? So report preview. If you click on report preview, it's gonna generate a report for you. So we can see it here, right here. Let's do this. Yeah, this one. Let's do double click here. You can see the report. So the report, you have your geometry, you have everything, the geometry, mesh and stuff. You can go here and see the graph and stuff. And even the image you can have. So you see, you have a lot of graphs here. You have the chart. You have these for the solution, and everything is right here. The table, tabular data. So let's close it. Let's go back to where we were. So if I click here, stress, we can see the maximum is here. We have the rate. And another tool that can tell you where is the maximum, you can go in results and then probe, max here. So this is the maximum. Mean, this is the minimum. If you look at probe, you can navigate, click probe, navigate here. It's going to give you in every node the stresses values. So this is the end of the tutorial. I hope that helps. That's the way you can simulate, beam, and we can see it went plastic in here. So yeah, that's it.